Hey everyone, today we'll be looking at sorting algorithms with Python. Just a quick demonstration. I will algorithmically generate a list of not 10 million, 5,000 random integers between 0 and 100 and store it in a file. This will do that for us. Let's just quickly run it. And here is our random list of numbers, all 5,000 of them. It's stored in this file, random underscore list.txt. And our sorting algorithm here, is going to sort it for us. We are going to open the file, write it into an array. After that, we're going to keep track of time. And then we're going to use bubble sort and quick sort. We'll talk about all these here in a moment. And then print the first 200 the 200 elements of the sorted array. Let's just run it. As you can see, the quick sort took about 3 microseconds or something like that, 4. And here is the sorted version, which is correct. So we took all these numbers and sorted it. This is the first 200 of it, elements. Let's just try the bubble sort instead and see what happens now. If you run it, as you can see, now it's stuck, it's taking its time, and it took a total of 3 seconds to do the exact same thing. And if you look at here from geeks.org, there is something called the time and space complexity of algorithms. In this case, it refers to how fast the algorithm will execute in the processor and also how much memory it's going to take while doing it. So as we can see, bubble sort is a O of n squared time. And the reason for that is, if you look, there's a loop within a loop. And what this does is, we have 5,000 elements in a list. We have to iterate over all 5,000, and then we have to reiterate over the 5,000 again. That's why it is O of n squared. Let me zoom in here. But on the other hand, quicksort is O of n log n, which is much faster, which is the next best thing after the square. And as you can see, because the reason is, if you see, we are actually using what we call indicators to traverse through the array, and we're not having nested loops. This is why it takes much quicker time complexity to do this. So anyway, we'll also use GPT-3 to write us some sorting algorithms, because as you saw, there are many sorting algorithms. So I just said to GPT-3, the code DaVinci 002 with a little bit of temperature, give me a list of Python sorting algorithms for a list of integers along with their implementation and their time and space complexity. I just commented first bubble sort and then complexity, so that just to prime it, let's just give it 500 tokens, and then let's see what happens. So it's going to give us, well, we'll have to wait for it to finish. You can also try it in ChatGPT, but it's just that when you do it in ChatGPT, after a while it breaks, and even when you say continue, it just doesn't continue exactly from where it left off. Anyway, so bubble sort complexity, O of n squared, space complexity, O of 1, which is true. Next one is selection sort. Let's see, selection sort is O of n squared with O of 1. So here are some different strategies. There's merge sort. Okay, maybe we can, so merge sort is supposed to be O of log n. Let's grab this real quick and try it to see if it works. Bring it here, maybe paste it right underneath. And we'll change this to merge sort. Oh, it didn't finish. Here we go. We'll let Copilot finish it. Cool. Save it, run it. Here we go. We got the same thing. So this is not as fast as quicksort. So let's just, hopefully this made it clear how the different sorting algorithms sort of work. You can also read more about them, but let's talk more about how we created all these, right? For example, let's create a list of 5,000 random integers between 0 and 100 and store it in a file, I said. So we need to import random. Copilot is going to do all this for us. Import time, and let's say keep track. Well, we don't need to import time for this. Okay. See, when it does this, so this is its first suggestion. Let me delete this file real quick. And if we run this, this will work, right? And it creates a random list. This looks perfectly okay, but if you come to the end of it, it puts a comma right after the last integer. That is not what we want, right? We want no commas after the last element. So to do that, we can actually do it ourselves. Like we can say for I in range. So we can make an if statement if I is less than 4999, because range is upper bound exclusive, right? Or we can just say do not use comma after the last element, and it'll actually do it for us. Here we go. Yeah, so if it is the last element, it'll only write a random integer, and until the last element, it'll write a random integer and then the comma. So now if we save this and run it, as we see, there's no comma after that. So that's cool. Now, as far as what happens here, let's just begin from scratch. We don't need that anymore. So we want to open an array from the file randomlist.txt, which we already have created. We will use sorting algorithm sort the array. So keep track of time. So it wants to import time, sure. That's what we want. So it's going to open it and read it. Read the file as a string. You see it's reading it as integer. Let's print the array. Let's print the first 10 elements just to see if it is working. Yep, it is. That's good. So let's grab the bubble sort here, right? Before we're doing the bubble sort, let's do sorted array. You know, Python already has the sorted method, I believe, sorted array. And if we print sorted array first 100 elements, this should work. Yep, as you see, let's do the first 200. Yep, this works, as you can see. So this is a built-in method, but we are going to use the bubble sort. So let's just paste it here. This is the bubble sort that GPT-3 wrote for us. Now we're going to say sorted array bubble sort, and then print. Let's do it like this: sorted array, first 200 elements, and then the time it took. Import time. So before we sort it, we want to keep track of time as start time with time.time, and then after as end.time. And now here we can say time end time minus start time. So this is how long it took. You can say, well, we can just leave it as time, save it, So as you see, it's working, and it took 2 seconds to sort it. Let's try again. Okay, 1.9. So it depends on the load on your processor, what kind of processor you have. So this works, right? Let's now try a different one. Let's try selection sort. I'll just paste it here. Let me fix the indentations. Selection sort. Okay, if we run this, see, this is a bit quicker. Awesome. What else? Merge sort. Let's just let it continue writing. Quick sort. Okay, it wrote it differently this time. It wrote a helper statement. Let's grab this. Bring it here. Paste it right here. So partition here is a helper method for the quick sort, right? As you can see, it's using it right here. Essentially, it's returning the array at this point. Okay, what is it? What do we say? Quick sort. Oh, it's taking 3 arguments to the first index and the last. All right, let's run it. Oh, it already had that. It's like, what is it, 1 millisecond, something like that. Let's run it again. Let's do something fun. The reason why the time and space complexity matters is, what if we, instead of 5,000, what if we had, let's say, 20,000? And you can also, in Python, you can put an underscore after the 3 zeros to make it more readable. Just a quick trick. Let's rewrite this part. That should work. Now, if we run this, it generated this time 20,000 random integers. Just make sure no comma after. Now we have 20,000 integers. What would happen with quicksort to sort 20,000 integers? Just gonna run it, and it just took like what is it, 100 milliseconds? Sorry, I'm like 0.1 second, pretty much. So it's pretty quick. Let's try the selection sort on it. Selection sort to sort 20,000 random integers. This is going to take a moment. Also, let's see, there's a loop within loop. So when it's n squared, as you see, that because the complexity is increasing logarithmically, I mean exponentially. Look, it took 16 seconds. On the other hand, before it was taking like something like 1 second or something like that, I believe. So it really increased the time it took. Let's try the bubble sort. Let's see how long this takes. So please read up on different sorting algorithms, and you can also search for time and space complexity of algorithms. And see, the time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of the length of the input. Similarly, space complexity of an algorithm quantifies the amount of space or memory taken by an algorithm to run as a function. So you can read about all that. It's really interesting. These stuff also come up in interview questions. Look, bubble sort took 31 seconds to do the same thing. We can, as a last thing, ask, I want to ChatGPT to write the best sorting algorithm it can. I want to sort a list of random integers in Python. There are a lot of them, so code me the most efficient sorting algo possible. Let's see. There are many efficient algorithms. Some of the most popular efficient quicksort, one of the fastest, merge sort. So we already used it then. Quicksort it is. As a last fun experiment, let's delete this and let's make 100,000 integers. Now we have 100,000. Fantastic. So we will, of course, not use bubble sort, but let's try quick sort on it. Let's run. Oh, there was a... Oh, it did put the... Oh, because we didn't change it. That's fine. We just didn't modify this part. It's okay. We saved it. It should work this time. Oh, my maximum recursion depth exceeded because it is a recursive algorithm. So 100,000 is too much. Let's do 50. Delete this. Okay. Yeah, look, 0.6 seconds. How about with selection sort? Let's try. Let's let it run while it's running. Sorted. So I essentially just use the included Python method sorted. I guess it would make sense that they would probably implement the fastest one. It's still running. I think it's probably going to run for a while, and it's almost 17 minutes into this video, so I will end it here. I hope you're enjoying the content as much as I'm enjoying making it. If you do like the content, please like and subscribe. Leave comments with your suggestions and your thoughts. And it's almost New Year. Now it's the 27th of December, so I don't know when you'll be watching this video, but I wish everybody Happy New Year, and if it is after the New Year, I wish you a great year regardless. So this is going to take a moment, obviously. So the last one took 16 seconds, so this might take a minute or two. Just give it another moment. Yeah, like I said, read on the time and space complexity and sorting algorithms. You can also try to, as an exercise, try to write your own sorting algorithms. It's a pretty cool exercise, in my opinion. Here we go. It took 99 seconds. Minute and a half plus 9 seconds. So this is the power of knowing space and time complexity and not using nested loops if you can use other methods like functional programming or recursion. Anyway, we'll end the video here and take care. See you next time.